All right, welcome back everybody. My name is Dustin, and in the last video, we ended up working on getting the triggers to work. We ended up making the event manager, and we did all that in Lua. And I also left you with a couple challenges. So the first challenge was if the player falls, we want to be able to set them back to the start position, right? So if we come here, and if we fall, and the player falls and he hits a trigger, we want him to go back to the start position. So that was one of the first challenges. So let's quickly do that. That one's going to be pretty easy. So we basically have these activations, and that's what we're doing. So what's happening is, if we go to main.lua right here, and down here, so what's happening is, so we're getting our user data back from our contact listener, and we're getting the UDA and UDB. UDA and UDB are actually object data. So that's the struct that we're actually using for our data. You can use any type, but the way that I have it set up is for the object data, okay? And then what we're doing is we're doing a collision event, and we emit an event, and then we send these objects to all the subscribers, okay? Then into our trigger system here, what's happening in it, on collision, we're checking to see if it's a trigger, and then we're triggering the player. But we're not doing anything with it yet. So the first thing we want to do here is actually adjust the transform of the player, okay? So that was the first challenge. And that's actually pretty easy. So we're just going to do it in here, but in reality, on player trigger, there could be more than one style of trigger, right? So you probably want to have another function here which checks the style of trigger and then calls that particular function. But right now we're just going to change the player position, and it's pretty straightforward. So all we want to do is first go local, and we'll say player entity, and that's going to equal to our entity, and it's the player dot entity ID. Okay, so then we have the player. We want to get the physics component, so local physics, and that's equal to player entity dot get component, and then that's our physics comp, physics comp. I want to make sure that's what I called it. I always forget. I think we're doing that in main. Physics, yeah, physics comp. So we'll go back, and then what we're going to want to do is go physics set transform back to. And then we want to go to our start position. And I know our start position is 16x and 416y. You can make that into a variable if you want, but I believe that's what we did. So up here, where's our player? G player. Yeah. G player position 16 and 416, and that's basically what I did. Is I went to the tile map and I just looked to see what the coordinates were for the position that I wanted the player to be in. Okay, so then we go back there, trigger system, and there's a problem with set transform inside of Box2D. So what I like to do, because setting a transform of an object isn't really physics, so it actually has there's a problem with it. What I like to do is just do a linear impulse after, and just do vec2 and just do 0 and let's say 5. Let's see if that does the trick for us. Oh, we got some errors. All right, so we got an error here. It's trying to call set transform, and that's the problem right there. We actually never set that function up in our physics component. So we need to go back and create this function here, set transform. So we'll copy that, and then we'll open up our physics.cpp, and we'll scroll to the bottom. Let's see what we got, all our functions. Yeah, so right down here, we'll just say new function, and we'll just say set. I already have that copied, set transform. That's going to take in our physics component, physics component, reference, physics component, and it's going to take in a const glm vec2 reference for the position. Okay, so we're just creating a little lambda function here. First thing we're going to do is the same as this. Might as well just grab all this. So, and then when setting the transform, we also need to make sure that we get the screen width, screen height, and the pixels to meters to offset our screen or our camera or our world coordinates to the Box2D coordinates, because they are different. So what we're going to want to do is go auto reference engine data is equal to for engine data get instance, and then we want to go const auto reference. We'll say P2M or pixels to meters, and that's equal to the engine data dot pixels to meters. Doesn't really need to be a reference. So now we want to get the scaled width and the scaled height from the engine data, but we're going to want the half width and half height. So const auto scaled half height is equal to engine data dot scaled height. And then we want to multiply it by 0.5 f. And we copy this down and get the half width. Half width. So since we're actually changing the position to a given position in the world, we need to adjust this position on the pixels to meters minus the scaled width and minus the scaled height. So we need to go auto bx for body x is equal to position dot x times p2m minus scale half width, and we can put this in parentheses. And we need to do the same thing for y, height, y, and now we want to set the transform. So we go body, set transform, and this takes in a b2 vec2, bx, by, and it also takes in an angle, but we don't care about the angle, so we'll just send in a 0. Okay, and that should compile, and let's see if that works now. Oh, it didn't like the b2 vec2. All right, so let's compile this. All right, see if it works. And it put us way up there. But it did transform. That's what I like to see. Good. So let's follow down over here, make sure it does it as well. Cool. All right, so we're transforming, but not to the right place. So let's see what we're doing wrong there. Yeah, there we go. Copy and paste issues. So that's my fault. So this should work now. That should have been Y. All right, so we'll just fall in. Bam, there we go. Perfect. And that's it. So all we had to do there is, I forgot that we didn't have the set transform function already created. So we had to create that function to set the transform of the player. This isn't really the best way to do this here. So if we go to our trigger system. So you got to think about it like we would want to put another way to move the player to the desired position. This wouldn't really be a good way. So we'd want to actually load all the triggers for the scene, and then we'd want to have a function or a map or actions or a table of some sort that holds the functions that we want it to do. So each trigger will have its own like position. Like it's not always going to be this. This is like a hard code. We wouldn't want that, but we're going to go over that in another episode, where we can actually call it in a better way. This way is just temporary to show that we can get done, but there's going to be a better way to do this later on. Okay, so now the other challenge was this. So say we're in the game like this, and say there's a trigger right here, and you hit the trigger, but there's also an enemy, and you hit the enemy. Well, currently, we're only looking at one contact at a time, right? Because the way that we have it set up, it can only see one thing at a time. So if there was two things that would affect the player, one might only be triggered. It might not be fast enough to get both of those because we only have the one contact. So what we need to do now is add a way to have multiple contacts, okay? So let's quickly go to our user data here. If you think about it, we really want to keep it in the object data. And what we can do, part of our object data, is we can actually keep track of object data. So that's what we're going to do, okay? So what I can do here is just create a vector. So let's add vector in. So include vector and add a new vector. So std vector. And this is going to be a vector of object data. Okay, and that's going to be our contact entities. Okay, so let's actually do this as well. Let's put this in its own file. And we'll say namespace Scion physics. Grab this, place it in. Cool. All right, so let's go back to here. So what we're going to want to do is take our contact entities, and inside of our contact listener right here, whenever we begin contact, we want to take the other contact and place it in the other one, if that makes sense. We want to add it to the contacts. So each will have more contacts, if that makes sense. So yeah, in the contact listener, right here on the begin contact, before we set the user contacts A and B, these we're just setting our user data. But inside of here, we're going to actually want to add the contact. We're going to want to add A to B and B to A because they're currently touching, right? And then when we end contacts, we want to remove them both from each other, okay? So let's go back into our user data here and create a couple functions to help us with that. So the first thing I'm going to want to do is create a comparison operator. So we can just go friend, bool, operator, equals, and we'll say const object data reference A, const object data reference B. Okay, so we'll have that, and then we're going to have a couple functions here. We're going to say void add contact, and it's going to just take in a const object data reference, and we'll just say object data, and we'll have another one, and it will be remove, and we'll just put this as bool. We'll actually make both of these bool, and this one will be remove contact. Cool, so let's create all these three. All right. Now, I wanted to create the comparison operator because I don't want to add object data into the contact entities if it is already in there. Okay, so we need a way to check it. And what I want to do is just say return a.b collider is equal to b.b collider. And I'll just bring this down a line so it looks cleaner. And a.b trigger is equal to b.b trigger, and a.tag is equal to b.tag, and a.group is equal to b.group, and a.entity ID is equal to b.entity ID. Okay. So what it's going to do is check all of these things. You could probably just use the entity ID in reality, like they're all going to be unique. However, I want to just check all of it just to make sure. Okay. And then we're going to have our add to contact and remove contact. Okay. And the first thing I'm going to want to do here is say auto contact iter equal to std find if, and we're going to send in our contact entities dot begin, contact entities dot end, and we're going to take in a reference, and we're going to say object data reference contact info, and we'll say return contact info is equal to object data. Okay, cool. So here we want it to be equal to end. So we want to say if contact iter is equal to contact entities.end. So we'll say if not, and then here we're going to return false. And if it makes it to here, we just want to push back the object data. So we go contact entities, push back object data, and then return true. Cool. All right. So for the remove contact, it's basically going to be the same thing. However, we're going to have to erase the contact. And we can just put this in here. And we can say remove if, because they both return an iterator. And this is going to be the opposite. If it's not there, there's nothing to remove, right? So if contact iter is equal to the end, then this object data does not exist in our contact entities, so there's no need to remove it. Otherwise, we're going to want to say contact entities erase, and not object data this time, the contact iter. Okay, and then return true. All right, there we go. So there's that. Let's just build this to make sure it compiles. All right, so it built, that's good. All right, so now we actually have to go to our contact listener and make some adjustments in there, okay? So we're gonna do everything the same here. However, now what we need to do is we need to get the object data from this user data here. So we need to do an anycast, but I'm gonna put it in a try catch block. The reason I'm gonna do this is because when I was doing some of my testing, when you shut down the program, sometimes it's still trying to do the anycast and it was throwing exceptions. So I'm just doing this to catch the exceptions if they happen. So we want to go const std bad anycast reference exception. And here, what we want to do is get an error. Do we have the logger attached to this? So let's go to our physics. And I'm not sure if we actually added that in reference, and no. So let's reference the logger. We've done this before. So we'll go here, go down to properties, all configurations, C++ directories, and let's add in our logger. Go back one, get your logger. Cool. Then adjust this to the solution dir. Cool, that should be good for us. Now we have our logger. So include logger.h. Now we don't have to log this. I'm just doing it just in case, okay? You can also just use std cout if necessary. And then we can go Scion error failed to cast user contacts. And then we'll get the error, ex.what. Cool. And then we want to set our user contacts here. So set user contacts just to null pointer. And we're going to move this actually inside of our try catch at the bottom. So the first thing I want to do here is actually cast both A and B data. Okay, so we want to go auto a any is equal to std anycast object data or data and a data user data. And we want to do the same thing for B. B. Cool. Then here we want to say A any add to contact. That's going to be B any. And then we want to do the other way around. And then we just want to make sure that A data user data, let's reset it, and then just set it again, A data user data is equal to A any. So what this will do, it will destroy the data that's already there and then add in the change it to this data. Now, I'm not sure if this is absolutely necessary, but we're going to do it this way. And do the same for B. Cool. And that's it for adding in our contacts. Awesome. In our end contacts, we basically want to do the same thing. However, we want to remove the contacts, okay? So let's grab all of this. Actually, let's grab all of this. So we can just copy over this because we're going to be using that anyway. We're setting them to null pointer anyway. Well, I care about the data because we're not getting rid of the data itself. We're just setting the contacts to null pointer. That doesn't mean that we're setting the underlying data to null pointer, just what we're currently pointing at. Hopefully that makes sense. Okay. We didn't get the A data, B data before, but we need to get that now. And we can just do that up here. We can get rid of this. That's not needed. And instead of adding, we want to remove. Now I know we made these bools, like you can actually add it in to see if not. So we can go if not. And then you can just log some error here. That's what the logger is really for. Log an error. But we don't need to use that yet. And if it's not working, then we'll start logging to see what's going on. To do log error. Let's copy that just in case. Whoops, what am I doing? Let's go back here. Cool. And that's really it. That's all we had to do for that. And we're already setting it to null pointer here anyway, because that's what the end contact is doing. However, before that's done, I want to remove it from my contacts, okay? So this should build. And it should actually still work the same way with the way that we have our scripts right now. We're going to want to adjust it, but it should still work because we still have the tag, we still have the data. We're still setting this here. All we did was add in a new variable to our object data. So if we drop here, it should still work. Yeah, see, it's still working, still doing the same thing. But we forgot to add in our object data binding. So we added the new contact entities. Well, we need to bind that as well. I believe we did that in the physics component. So let's find that. Let's go to our physics component. And I believe it's up here. Yes, right here. So we need to do our object data as well, or not our object data as well. We need to do our contact entities, and we can just do that, contact entities. And we need to send back the object data, contact entities. Now this should work because we've already bound the object data as a user type. So it already knows what these are. So it's object data that points to object data. Okay. So what we can do now is a little test. So let's go down to our, let's actually just build this, make sure it compiles. Awesome. So we're compiling. That's great. And it should do the same thing. Cool. All right. So let's go into our main.lua down here, and we'll get rid of these now because we know that works. And we can just comment this out for now because I don't want it to do anything. And I just want to go through the contact entities, make sure that works. So we want to go for KV, or key value, in pairs. And we want to now say UDA dot contact entities. And we want to print some stuff out. So we'll just say print UDA tag. And that takes in v.tag group v.group and we'll copy this, put it down here, and this is B. So these are the contact entities, or we'll say B contacts. Copy that. A contacts. And before we do that, we'll also print out what UDB tag. I'll just copy that. And this will be UDB. Let's copy this and do this for A as well. So what we're doing here is we're going to print out all the entities, the entity that it is here, and everything that it's touching at that moment. Okay? That's the goal. All right, so if we stop here, we see that we have our player and it's touching colliders currently, and that's UDB. UDA is collider and it's touching the player. Does that make sense? So if we go down here and follow, let's bring that up again. I'm losing it. So we'll start this over because I kind of messed up there. Run it again. Yeah, so if we move this over and I come over here and fall, see how we're touching multiple things at the same time? And so take a look here. So now we have our tag player is touching hold triggers and contact player, the hold triggers is touching the player. All right, so that's all we really have to do for that. So that's working for us the way that we want it to work. And if we go back here, we can actually just take this all out for now. And just do our collision event, and it should work by moving our guy like before. Cool. So the next challenge for you guys would be to use these new contact entities inside of our trigger system instead. So in here, instead of just using the A and B tags, have it loop through the contacts that it's currently touching and then send out triggers based on that. Okay. All right, so that's it for this video. And I'm not really sure what I want to do in the next video, but I'm thinking that we start getting into actually doing the editor and slowly making our tile map editor. So we'll start getting into IM GUI and all of that stuff. So I'm considering jumping into that. If you want to look at something else first, let me know. But I'm going to start working on those videos very shortly. All right. So if you like that, give it a good like and subscribe, and take it easy.